So in previous lecture I discussed about finding the sine series. So sine series is same as Fourier expansion of odd function. Now the question is to find the cosine series. You have it means you have to use a Fourier expansion of even function. So how if the see if the question is to find the half range series, it means you have to find both sine series and cosine series. So already we have got the sine series. I have discussed that in the previous lecture. Now cosine series formula, f of x converging to a naught by 2 plus summation 1 to infinity a n cos of n pi by l x, where a naught 2 by l integral 0 to l f of x dx a n 2 by l integral 0 to l f of x cos of n pi by l x dx. So l is 2 here. F of x equals x is defined in open interval 0 to. So l is 2. So a naught is 2 by 2 integral 0 to 2 f of x dx. So 2 by 2 is 1. F of x is x from 0 to 2. So integral 0 to 2 x dx, that is x square by 2 from 0 to 2, that is 4 by 2, 2. So the Euler's constant or the Fourier coefficient a naught is 2. Now coming to a n, 2 by l integral 0 to l f of x cos of n pi by l x dx. So l is 2. So 2 by 2 integral 0 to 2 f of x is x cos of n pi by 2x dx. So here we have to use Bernoulli rule u v1. So x into integral cos sine of n pi by 2x by n pi by 2 minus u dash derivative of x is 1 integral sine minus cos of n pi by 2x by n pi by 2 whole square from x equals 0 to 2. And 2 by 2 gets cancelled here. So here we have used Bernoulli rule u v1 x into sine of n pi by 2x n pi by 2x by n pi by 2 minus u dash derivative of x is 1 integral sine minus cos of n pi by 2x by n pi by 2 whole square from x equals 0 to 2. So sine function is 0 for both the limits. When x is 2, sine n pi 0. When x is 0, sine 0 is 0. So the first term is 0 for both the limits. Second term 4 by n square pi square cos of n pi by 2 into 2, that is cos n pi minus cos 0. So minus 1 whole power n minus 1 by n square pi square into 4. So 4 times minus 1 whole power n minus 1 by n square pi square, where n is a positive integer. So I have told you many times, whenever you have minus 1 whole power n plus or minus 1, you should discuss odd and even case. So the bracket term is 0 when n is even. The bracket term is minus 2 when n is odd. Say take for example n is 2, minus 1 whole square is 1, 1 minus 1 is 0. If n is 1, minus 1 minus 1 minus 2. So it is bracket term is minus 2. So we have got a naught and a n. So we know that a n exists only when n is odd. So what is a cosine series? Same as Fourier expansion of even function. A naught by 2, a naught is 2, so 2 by 2, and a n exists only when n is odd. So 1, 3, 5 etc. to infinity. And what is a n? Minus 8 by n square pi square cos of n pi by 2x. That is 1 minus, you take minus 8 by pi square out, summation 1, 3, 5 etc. to infinity 1 by n square cos of n pi by 2x. Expand the summation 1 by 1 square cos pi x by 2 plus 1 by 3 square cos 3 pi x by 2 plus 1 by 5 square cos pi x by 2 plus etc. So here whenever the question is to find cosine series or half range series means you should find both sine series and cosine series. If you have to find sine series, it is same as Fourier expansion of odd function. So the graph will be symmetric about the origin. If the question is to find the cosine series, you have the graph f of x equals x defined in open interval 0 to make it symmetric with respect to y-axis. So you construct the graph in such a way that for getting cosine series, the function should be an even function. So make it symmetric with respect to the y-axis. So we have the new function defined in interval -2 to, which is an even function. So we know the Fourier expansion of even function, so which is also called as the cosine series. So I have today's class, I have discussed one problem for half range series. So remember, half range series is for aperiodic functions, non-periodic functions, or you are given a function defined in half the period, you are making it periodic by extending it in the other range minus L0, which is either symmetric with respect to y-axis or symmetric with respect to origin, so that you get an odd function or an even function. So you know the Fourier expansion of odd function and even function. So Fourier expansion of odd function is called as sine series. Fourier expansion of even function is called as the cosine series.